Welcome to the show. Today we're diving into the fascinating world of knowledge graphs and a groundbreaking model called KGICL. Joining us is Dr. Alex Thompson, an expert in AI and machine learning. Dr. Thompson, could you start by explaining what KGICL is all about?
Absolutely, and thanks for having me. KGICL stands for Knowledge Graph in Context Learning. It's a model designed to tackle a big challenge in the world of knowledge graphs: reasoning across diverse graphs in a universal way. Traditional models struggle with transferring knowledge between different graphs, especially when they encounter new entities or relationships. KGICL introduces a novel approach using something we call prompt graphs and a unified tokenizer to address this.
That sounds intriguing. Can you tell us more about these prompt graphs?
Sure thing. Think of prompt graphs as specialized maps that help the model focus on what's important. When you have a query, the prompt graph hones in on relevant examples and context related to that query. This helps the model understand and reason about the relationships involved, much like how we use context to make sense of new information in our daily lives.
So how does this approach help with the main challenge of generalizing across different knowledge graphs?
Great question. The main hurdle is dealing with unseen entities and relations. Traditional models often falter here because they rely on specific vocabularies tied to particular graphs. KGICL uses a unified tokenizer, which acts like a universal translator, mapping all entities and relations to a consistent set of tokens. This way, the model can apply its reasoning skills across various graphs without getting tripped up by unfamiliar terms.
That's clever. What were some of the key findings from your research?
We found that KGICL significantly outperforms existing models on most datasets. It excels in both transductive settings, where the graph structure is known, and inductive settings, where new entities appear. This demonstrates its superior generalization and reasoning capabilities.
Impressive. But what obstacles did you face along the way?
One major obstacle was dealing with noise from irrelevant relations in global relation graphs. This noise can mislead models, making it hard to extract meaningful insights. We tackled this by focusing on local contexts and highlighting the relations most relevant to the query at hand.
How do these improvements translate into real-world applications?
The implications are vast. Imagine dynamic personal knowledge graphs that evolve with user interactions, or recommender systems that better understand user preferences. KGICL's adaptability makes it ideal for these scenarios, enhancing the ability to provide personalized and accurate responses.
What about the future? Where do you see this research heading?
We're looking at refining these techniques further, perhaps integrating more sophisticated in-context learning strategies. The goal is to make KG reasoning models even more adaptable and capable of handling an ever-growing variety of tasks and datasets. The potential applications in AI-driven decision-making processes are truly exciting.
Thank you, Dr. Thompson, for sharing these insights. It's clear that KGICL is paving the way for more versatile and intelligent knowledge graph applications. We appreciate you joining us today.
Thank you for having me. It's been a pleasure discussing this exciting development.